class is going to be a small one. We won't have a long one. We'll just do some part of the NATing, not the full complete one. Okay? We'll do a recap of what we have done before, but let me explain to you the physical topology before we move. Physically, my two racks that I have, they look like this. Two beautiful little boxes, number 1 and 2, switch 1 and switch 2. Supposed to use this. No. Let's do this. Asli boxes use. ठीक है, thank you. So what I'll have is one box is here, the other box is this one. Between the boxes, what do I have? Routers, right? So I have R1, R2, and I'm using R4. I don't have R3 because I use the console of R3 already. Okay, so this is 1, this is 2, this is 3, 3 routers, and I'll be using the firewall which is connected right here, the ASA. Three and four connections to the ASA. This is switch 2, switch 1. The connections are, this is connected right here, it's connected right here, it's connected right here. Okay, so R1, R2, R4 and ASA1. E0, 1, 2, 3. This is 10, 11, 12 and 13. This is my physical. The logical that I'm going to create is simple. You know that already. ASA in the middle, R1, R2 and this is R2 and R4. ASA. Simple. So how do I do this? Yeah.
ASA में कंसोल है जो जिससे आप
वो 3 में रखा हुआ है मैंने R3 का कंसोल निकाला वो ASA में डाला. To cut the console of R3, I put it into console because I didn't have a console to ASA. So let me rename it so we don't get confused. IP host ASA1 LB 2 0 10 11 1 1. So ASA1. Right? So that is my ASA. Tell me the VLANs. Say I'll have this in 10, 20 and 40. 3 different VLANs. Now since this is connected already, this will be F00, F00 and F00. I could have done it with 1 also, but I'll do it with 0 because that's how we have been doing it until now. Tell me now which ports and what VLANs? R101, which is this and this in VLAN 10. right? Then R2 this and this one. So this is E0, E1 and E2, 0, 0. Finally this, which is this, plus E2. E2 is right here. Connect them together. Okay, so logically it'll be like this. This is connected here. This is connected to this part, and this is connected. Right, which will make something like this. If you have a look, if you expand it, it'll be exactly this. Smooth these. Okay, now keep the logical in mind. That's what we're going to be doing, and we've been doing that for a long time. If you want, draw it out on your copy and keep it in front of you. Write out neat tree in front of you and keep it so that whatever we do, it'll be easier for you to check it while you're doing it. Draw a very neat diagram. Obviously you won't be as neat as me on this, so try to match this at least. Not the physical, I don't care about the physical. Logical. By the time you do that, I'll put everything in the wheel, in the cording VLAN. So zero, 1, switch port mode access, VLAN 10. VLAN 20, 4, 40. One, 2, 4. I don't need 30. I don't need 150, so I don't even need those ports. Right? Show trunk. My trunk is 23 set to the other side. So my trunking is done. I don't have to worry about that. Let me go to switch 2. Fresh from the box, good. Happy with that. Host name switch 2. Show VTP. It will be already settled. Why? Because there is a trunk. On the trunk it negotiates everything else. It gets the VTP domain name and everything if there is a trunk already. Right? It was a new switch, so VTP was null. They took it from the other side. Show VLAN brief. It should not have 150. Yes, because I removed it from that side, so 150 is also gone from here. Interface FA 0, 10. 10 is Ethernet 0. Switch port mode access. Have you copied the diagram? Switch port access VLAN 10. Again, interface FA011, switch port mode access, switch port access VLAN 20, then E2, which is 12, switch port mode access, switch port access VLAN 40, show VLAN brief. That my logical topology is set up, the one which you have on your paper right now. That topology is set up already based on VLANs. Okay, let's configure IP addresses. Before I do that, I'll have to do one more thing. I'll have to reload all my routers. Because there's previous configuration on it. I don't want it hindering anything else. R4. Okay, so R1, R2 and R4 are getting back up again with a blank config. In the meantime, let's configure the PICs. Now the IP addressing scheme that I'm going to be having, let me make this on GNS. I won't use it, but just for reference. What I'll have is something like this. I'll have the firewall in the middle. Then R1, R2 and not R3 but R4. This is connected to E2. E1 is connected to this guy. E2 is connected to R4, E0 is connected to, this is my logical. The addressing scheme is going to be 24. This side, since this is the DMZ, and finally the internet will be 150.20.24 with a loopback of 24. Okay, plus we'll also have loopbacks on each of the routers. 1.1 here, 4.4. Okay, now my topology is set up. I need to give IP addresses. Let's start from PICs. Go to the ASA, interface Ethernet, gigabit Ethernet, 0, 0, 0. The first one. IP address is 10, no shut, name if, inside, security level is 100, which is good enough for me. Then gigabit Ethernet 01. IP address is pointing down, so 150.1.20.10, no shut, name if, security level 0, good enough for me. Again, interface gigabit Ethernet 02. IP address 4.10, no shut, name if, DMZ, just DMZ, I only have one. Security level should be 50. Show name if 100.0.50, show IP, I have 10, 11, 11, 10, 151.20.10, 192.168.4.10, which is good enough. Are they up? All of them are up. Right? Now, if we have this, if I've configured this, let's check from R1, can I reach the firewall? R1 is new up. Enable R1 interface FA00 10 11 11 1. Good. Any questions so far? Default route? I won't have default route. I'll just have interface loopback 0, IP address is 1.1.1.1. Let's ping. My firewall is reachable from R1. How about R2? IP address is no shut. Didn't need to do no shut. 150.1.20.2. This is the outside. The loopback I created was wrong. So interface loopback 0 should be 200.1. Good. Let's go to what? R4, which is the DMZ. FA00 IP addresses no shut interface loopback 0 4.10 should be reachable. Is not. Why is not? (40) on VLAN 4. (40) on 12, which is E02. E02 is 40.10. Can I reach 20.2? I can reach 20.2. 4 dot. Can't reach 4.4. If I can't reach 4.4, I can fix it by doing this. I'll go to switch to interface FA04. I'll use it from the other interface. I have the other one, right? So F01. Maybe there's a connectivity problem. So on R4, I'll go there in default interface FA00, interface FA01, IP address. No, the problem is with the firewall. This is fine. 1, 2. Maybe that is not 3. Maybe let's try the other interface. Interface G02. (03) ट्राई करते हैं. Yeah. Interface FA 10, 11, 12, 13.
13.
No, it should be 12 because I've only connected it to 12. But still, let's do that. VLAN 40. Okay, that was the problem. So interface IP brief. Everything is the same. The only difference is that this is not E2. This is what? E3. So change it on your diagrams also. Everything else is okay. Name if DMZ, everything. Security level is security level. की ना मैंने changes की. No. 03 security is 50. So now my logical is set up. Logical is set up. Now what do I need to do? NATing. Normal NATing. Good old NATing. Let's create a node back. For dynamic NAT, my task is all my internal users on the inside should be able to access the internet by using public pool of 20.50 to 20.55, right? All my internal users on the inside should be able to use this pool. How did we do this on 8.2? Global outside 1 dot 150 20.50 to 20.55. Then I said NAT inside 100. Either I can say 00A, or if the inside network is specified, you can say 10 11 11 0 255 255 255 0. You can do both, but here it says all, so it should be 00. On 8.4, the process of NATing and the way it is applied is totally different. It's totally different. You saw the differences between the other things. Transparent firewall was not too much different. MPF and zone-based, everything else that we did is the same, exactly the same. The big difference comes in NAT. What is that big difference? Do you remember when a packet goes out? What was the first check? ACL. I'm talking a new connection. ACL and then security check. ACL, security check, and then in this, in 8.4, this block is removed. It's brought all the way here. It's brought all the way down. So first security check. If it's not allowed, then NAT. Then ACL. Okay, let's see how this affects. Right now, just remember this happens. Going from inside to outside, it won't cause any problems. Coming from outside to inside, you'll have to do something different than you used to do it in 8.2. Everything else will remain the same. The only difference that you'll have to do is coming back in when the traffic is coming back in. For now, everything is okay. For now, we don't need this. Just keep this in mind. NATing happens first, then ACL. In 8.2, ACL is applied first, then NATing happens. Okay? Let's go ahead and do this. Now internal users want to go outside. First of all, I would require a default route. 1.20.2. Why? Because if I want to go to, how would I go? I would need to go to. So ASA should have connectivity to the internet first, then the other users. Good? Let's try. To do this here, the command is called object network. You create something which is known as object network. Object network is not important. What you do after the object network is important. Under the object network, you can either create a pool or you can specify the inside users, or you can specify the static inside user. You can either specify the pool of addresses. So global will also use object network. NAT will also use object network. Everything will use object network. Inside object network, what matters is if you use the keyword pool, not the pool, sorry. There's another keyword, I'll tell you what that is for the pool. If you want to specify the inside subnet of users, then there's another keyword for that. If you want to specify one single static inside user, there's another keyword for that. What are those keywords? Right now, I'm doing it for the pool. First, I'll create the pool, right? The first step is global pool, which has to be created separately and NAT statement applied separately. So first thing is pool. Pool in 8.4 is specified by the range, by the name called range, by the keyword range. Pool becomes range. So you create the object network. You have to name this object network something. What is this object network for? What am I making it for? For the pool. I'm creating it for the pool, right? The name can be anything. But be sure whenever you give it a name, be sure so when you're looking in the running configuration, you know exactly what this object network is for. You should exactly know just by looking at the object network what is inside it. Because in the running configuration, there's object networks is separate and NAT is separate. So you'll have to go up and down, up and down. So make sure you know what your name is. I'll name it pool 20.0. This is just a name. Okay. Now this is where I specify my keyword. What did I tell you? Range, right? To specify the pool. My range is going to be 150.1.20.50 to, there's no dash, 20.55. That's all. This is just a name. Otherwise I could say dash. This is a name without spaces, so you can have anything. You can say pool dash dot because it's easy. Okay. So what did I excuse me. What did I create? Object network, then name it anything, pool. I named it wrong, right? Then since this is a pool, the keyword is range. Range. What is the range? Dot 1.20.50 to 20.55. This is equivalent to my global. But I'm not saying right now, I didn't say it's outside or inside or wherever. I didn't say that. I just created the network. Right, so let me just remove this first because I named it wrong. .150.1.20 and the range is going to be the same. Show run object. This is my global. I'll have to create another one. Object group, object network. I'll call it NAT I'll call it NAT. To specify the range of inside users, this, right? In my 8.2 I used to specify it here, NAT inside 1 0 0. In 8.4 I have to do this also separately inside a different object group. So one object group for global addresses, one object group for inside addresses. Now I called it NAT 1010, which is also wrong, which is yeah, I'll create another name. Object network NAT all inside. This object group will be natting everything that is inside. To specify that range, see, range command was for pool. For the inside, it's subnet. There's total three only three keywords. One is the range used for the pool. Subnet is used to specify the inside networks which you want to convert.
If we have so many networks, so we have to define
all different object groups.
We can't do 0 0.
You can. Subnet I'll say 0 0. Or I could say 10 11, or I could say it like this with the mask. Host is different. We won't use that right now. Right now this is why, because I wanted to use this. I want to match exactly this. And now since I only created the object groups, I also need to NAT. NAT command is used in this object group, not in the pool. So the second object group is not empty. Second object group has the inside users plus the NAT command. NAT inside comma outside. Which kind of NAT am I doing? Static or dynamic? Dynamic. And what is, now I have to see, this is my object group. I have to link it to the pool. Earlier I used to link it with that number 1. Here I have to specify the name of that pool. NAT my inside users to outside. My inside users are specified in this subnet. The outside users are specified where? Whatever I'm going to place here. What is the name of that? Dot 20 dot. That's all. Show run object. See, here you can't see that natting command. That's why this is a little weird when you check it. Now to check that NAT, you'll have to do separately. Let me write it on the notepad. So you did this, then is specified by subnet. So object network inside all, subnet is or and then here under this object network, not outside. If you do it outside, that's a different type of NAT. That's called twice NAT. We'll do that later tomorrow. This is NAT inside comma outside dynamic to 20 dot. Look at this, how this works. NAT my inside users. Which inside users? They are specified up there. To outside. Which outside? Right here. So this is high, low, high, high, low, low. It's not high, low, low, high. High, high, low, low. Or low, low, high, high.
But we are not calling this object network inside or out.
I am calling this, right? This is the object network.
That is for
the pool.
outside.
For the outside. Inside I'm specifying right here. The subnet.
But we are not calling it in the NAT statement.
No. Where? In the NAT space, when I say inside, he knows the inside is the subnet. The subnet that you have specified right here. See, let's not do it like this. Let's do it like this. This will be more clear to you. Subnet is the keyword for inside.
That's why taking on
He's taking it from the subnet, and dynamic, whatever is after dynamic, he'll take it from the object network group.
इनको NAT command inside हम decide नहीं कर रहे हैं. In the NAT command, we
Yeah.
don't decide inside, we decide on the outside. Inside
Yeah,
is
we
the-
call outside. Inside is automatically inside that object group. He takes the inside from the object group, from the subnet command.
If you want to define multiple networks, then will you be using the same command or will you be defining it by a
Multiple networks, no, that'll be different. If you want to do it on the inside, you'll be doing here.
Sir,
Yeah,
multiple subnet लिखी है ना, मतलब एक subnet फिर
एक ही के अंदर one subnet, second subnet, third subnet. Yeah, from the inside. Let me show you. First, let's see if it's working or not. The command is show NAT. Detail shows you what is getting it translated to what. Origin is 00 is getting translated into this pool. This is a good way. This was not there in 8.4. Show NAT detail tells you exactly what is getting translated to what. Okay. This type of NAT is also called auto NAT. The second is manual NAT, which is also your twice NAT. We'll do that tomorrow. I'll tell you what manual NAT is. Auto NAT is the one where you can only change your source. Manual NAT, you can change your source as well as destination. Just like twice NAT is the same as destination NAT. But don't confuse yourself right now, just for knowledge. We'll do that tomorrow. Right now we are just doing normal, simple, dynamic NAT. Let's see if this works. R1 is on the inside. Show IP route. I do need a default route. It doesn't have a default route right now. Default route pointing towards the firewall. 200.1.1.1. The first time it gets stuck, or it didn't get stuck. So it did go through. Enable line VTY04 password Cisco login. I'll also do one more thing on the ASA. I'll have a route. Remember this? Why am I doing this? So that if he comes in with that source, when the packet is coming back in, I know where to send the packet. For inside is this. For my DMZ is 4.4.4.
So,
Show NAT gateway. Yeah. How many translatable hits? 1. I have translated 1 until now. Okay. Now I wanna show you something. There was a problem with 8.2 which is solved with dynamic NAT. Let me give a default route from R4 also. That problem was, remember when inside interface was bound to the outside, inside could not go anywhere else,
Yeah.
inside could not talk to the DMZs.
That is normal.
That problem is solved with 8.4.
Here we need to define individual policies for the field.
You don't have to. With
Here we
this,
don't have to.
here you don't have to. There you had to. Maybe in an access list probably. You should have had a rule going to from R1 to DMZ or something. Here, don't have to. Here access is okay. Right? And there's no concept of NAT exemption or NAT control here. That is also removed. So they've made it easier to configure. It's just that you'll have to stay put on the, it's just new, that's why people are not getting used to the object network types. It's just new in the market. I mean, no one has been using them before. And it's easier if you do it from ASDM obviously, but troubleshooting is hard. Okay, let's have a look. So if this is done, ASA1, I'm able to go to, what will be my source?
151.50.
Should be 150.1.20.51. 50 is the first one. 20.55. He has two. I logged in from the other guy also. Now the good thing about this, the good thing I didn't log out from the, I didn't say exit from the last one, that's why. The good thing about this is he does not give out addresses one by one. So he doesn't give out 50, then 51, 52, 53. He gives it out randomly for extra security. He gives out the addresses from the pool randomly, not one by one. Usually you do it like 50, 51 sequentially. It's not sequential
That
here.
is easy to crack. That is quite easy to crack.
Yeah, but in that case people can know. They can guess what the IP range can be. If they know there's 10 devices, they'll know that your IPs will be somewhere between 50 and 60. But here they will not know because it can be anywhere between 50 and 55. One PC can get anything. Stealth is more important in security. Hide your IP. Good. Now the question that you put was, can we do this? Object, network, what did I call it? NAT all inside. All inside. I'll say subnet. I can only have one subnet per one NAT. One subnet. Now how does that help? How does that fix the problem of if you have something? You do the subnets one at a time. Create object groups and do subnets per, see, if I went in here, object, network, all inside. I'll say subnet. Maybe I had, right? Check the full running config. This is the natting part.
Above.
Yes, he replaces it. So you have to create another one, another object group, in which you'll say NAT, not NAT, object network. Call it NAT for 10, 0. Subnet for this will be,
Then in every object group we create, we'll have to define that pool.
you'll have to define what?
That pool. Yeah.
The pool will be the same.
It will be same, but we'll have to.
We'll have to call it
in every
in every
subject.
subnet, in every object group. We'll have to call it. So now I have two. One is that one and one is this one, right? I modified this one. Which one? I modified this one. I'll bring it back. I'll say subnet 2550 show run object. So I have two now, NAT all inside and NAT 1011. This one is doing for 10.11.11.0. This one is doing it for 10.11 111.111.0. Let's create that on R1, but from pix right. Let's go to R1.
You can't match with your access list.
Huh?
Access list.
Do I need an access list?
Match subnets.
Which, oh yeah, you can.
You can.
You can. That's policy. We'll do that later. It's not for now. 11.11.1. Done. Let's telnet. source loop back off 1 or 2. First time open. You'll also go with some other IP from the pool. So the pool is managed dynamically. One object group takes a value from the pool, the other object group takes a value from the pool. The pool is separate. It's called by different object groups.
We define a range for pool and we call the pool again and again.
We'll call it from different object groups again and again. Is this good? So 55 was given to that guy, this guy is given 50. If I could do it without the interface, first time, second time open, this will be 55, 52, anything from the pool. Right, so different object groups for different networks, 51. Okay? Clear? Let's go back to ASA 1. Show NAT detail. I have one which is doing from 10, 11, 11, 0 to this guy. I have another one which is translating from this guy to that guy. Why does this have is on the top preference? Because more matches, 10, 11, 11, 1. It doesn't really matter because they are two different networks. So if that one comes, this one will go. If this one comes, that one will go. Clear? Good. Now, this is what? This is dynamic NAT. What is the other one? Dynamic PAT. Now, okay, I have inside, I don't have a pool anymore. If I don't have a pool, I don't have anything, right? There's no pool, so everything is gone because I deleted all my object groups. No one from inside can go outside. But what I want to do is, all my inside users should be able to go out. I have one IP address, not the interface. Not the interface, I have another one. Without the interface, I have something else, which is say 150.1.20.50, only 50, one address which I have purchased. So I want all of them to be patted onto that pool. If it was normal dynamic NAT, let's create the task. Allow all the inside users to be able to access the internet by using one address on the outside, that is 150.1.20.50. Okay. Earlier, how did I used to do it? Global outside one, not interface, 20.50, and NAT inside 1, 0, 0. On here, object network, I can say PAT inside subnet. See, it's different here. Subnet is 0, 0. So NAT inside to outside. Dynamic. Do I have a pool? I don't have a pool. I just say much simpler. So all my insides on the outside should be done based on this side. If you follow that step, that terminology, it'll be very simple.
0, 0 is the same way we can define the subnet.
Yeah, same. You can also do subnets there. 10, 11, 11, 0 or 10, 1, 1, 1, 1, 0.
This NAT command would be the same, but we have to call it in other objects.
This, yes. For DMZ, you have to call it separately under different object groups. Good? Simple, right? Very simple. Let's go in here. Object network, pad for inside. The subnet is going to be 0 0, then NAT inside to outside, dynamic using 20 dot. All inside now will be able to go outside using that one. Show users .50. If I change my source, also 20.50. You can guess it by the time it takes to translate. Doesn't take much to translate this, takes much to translate dynamic. Good. All will be using that. What about, what if you don't want to do it like this, you want to do it per interface? By using the interface address on the outside. How do you do it? Dynamic interface, right? So yeah, one keyword, that's all. Do that here. Player configure object group object network pat inside interface. Subnet is 0 0 and NAT inside to outside. Dynamic but R1. No, first that one is used, the above one, the address. No, it's always, the preference is always given to the IP address first. Interface is the last preference. Dynamic pool is the first preference, then patting is the second preference. Yeah, then it goes back to the interface. That is, we'll do that in combo. Good. All of them will be using 20.10. This was dynamic. Simple. Any questions until now? Any questions? No? Next. What is the next? Pool first. If the pool is exhausted, move on to the interface. If the pool is exhausted, move on to the interface. Let's do that. Allow the inside users. I have not touched my DMZs yet. That will be in static. Allow the inside users to be able to access the internet at the same time using the pool. 50. We'll make a small pool, but we won't be able to check because we are on the rack, so it doesn't really make the difference. 20.53. Also, if the pool is exhausted, back this up by using port address translation on the interface. How did we do it earlier? First we created the pool, global outside 1, 20.53, then global outside 1 interface, and then we said NAT inside 1, then 0 0. That's all. Here, tell me, think about it and tell me, how do we do this here? What is the first step? Object network. What name? Pool. Which pool? 1.20 dot and range, right? For pool, the range, the keyword is range. 20.52, 20.53. Yeah. Done. Then object network, NAT, SPAT inside. What do I say? Subnet, then NAT inside, outside, dynamic, pool 20.0 and same command. Minor changes, very minor changes between the two. Pool plus interface. So you back it up using the interface. Let's try. Object network, the first one is pool 20.0. So range is 20.52, 20.53. Object network, NAT, PAT inside, subnet is 0 0, NAT inside, outside, dynamic, pool 20.0. I have the option of specifying the interface only. I don't have the option of specifying the IP address. So I can back it up only using interface. So he'll use something from the pool, right? There, 53. Good. So once the pool is exhausted, he'll come up and use something else. I can't, because I'll have to exit my session. I can't go to R1. Right? Now, if this is done, this is clear. I have that way. See, you might ask, why don't I, how can I do that? I want to do combo of all three together. I want to make sure first he uses the pool. Then I don't want to pat on the interface. I want to keep a separate backup for patting. So if I have 150, I have .50, .51, 52, 53. 53 I want to keep for backup, pat. 50, 51, 52 I want to use dynamically. He only allows me to do combo on the interface. Is it possible that I do the combo without the interface? Is it possible?
Yes.
How? How is it possible? It's possible, but in that you'll have to do something else. Now this concept, we'll use the same concept we used yesterday of object groups. Remember object groups?
Yes.
We group different objects together.
Yes.
That's why I showed you that yesterday, because today we are going to be grouping some objects together. Now which objects will we group together, that we'll see now. Okay? See, the thing is, I want this pool. Allow internal users to access the internet at 1.1.1. Excuse me. Hello? Now he wants to use the internet at 200.1 using the pool above. If the pool is exhausted, the ASA should use the address of 150.1.20.53 for PAT. Use the interface as a backup for this PAT in case this exhausts too. Okay, so first backup will be my interface one address, PAT address, then the other backup will be my interface. How do I do that? First things first, I need to create an object network for pool, which I have already done, only until 52. 53 I need to specify in another object network, but this will not be pool, this will be pat.1.20.53, and inside here it won't be range, it won't be subnet, it will be host. Host means one address. Okay, 150.1.20.53. I'll group them together. I'll group both of them together because I need to call both of them together. How? Object group, call it NAT pat pool network object. What is the first network object that it has? 150.1.20.0. The other one? pat.150.1.20.53. That's all. I've just grouped them together. So what did I group? The pool and that pat interface, the one which I want to pat later.
So host is the keyword.
Host is the keyword for one address if you want to put one address.
There will be one
Address. Host. दिखाता हूँ ना, इंटरफेस दिखाता हूँ. Final is object network NAT pat inside. What do? Subnet 00 NAT inside, outside, dynamic. Here what did I use to specify? Pool. What do I specify now? NAT dot pat dot pool. Both objects together, and back it up using good. कहाँ पे? यहाँ पे object group network, yes, because I'm grouping network objects together of networks. Good, let's do this. First, object network pool of 20.0, which is range 150.1.20.52 150.1.20.52. Object network SPAT of 150.1.20.53, which is host 53. So two out, I've created the two, I need to book them, link them together using object group with a hyphen. Type network, call it anything, NAT PAT pool. Network object, what is the name of the network object? It's called object pool dot 1.20.0, also PAT 20 dot. So I've grouped them together. Syntax error here, it's network dash object, network dot object, also object here, object here, two objects together, right? Now this is done. Then I need to create what? This third part, final one, which is object network. This will be NAT PAT inside, subnet is 0 0, NAT inside comma outside, dynamic. How do I match? Object group name, which is NAT dot PAT dot pool, and back it up by interface. See if it's working. So it should go using the pool first, then something else. This is from the pool, right? So if I had 2 or 3 users coming in, they'd be using the pool also. I could check. Is this clear? Clear? Combo? 2 types of combo I did. One was single interface backing up. Now I'm backing up using 2 different interfaces. One by backing up with the host, the other one I'm backing up using the interface. Even the host I'm backing up using an interface. Good? So combo NAT is also done. The last 2 that you're left with are the more basic, the more simpler ones. Yeah, but the only thing you have to be careful about is the access lists. Static NAT and static PAT. Okay, now we'll bring the DMZ into play. Till now the DMZ was not into play. Now inside are going outside. This is the one which I'll use. So they're using a pool to go outside, and they're also using everything else. So I will not remove this. I will keep it as it is. So inside users are configured to go outside. This is fine. These people have access to the outside network. Now I need this. I don't want him to allow access. I don't want to allow him access outside. I want people from outside should be able to access the DMZ for certain services. For certain services. First is normal, single, one service. Using the interface, not the interface. Interface is already used for inside. So I'll give another IP from a different range, and then I'll give it to whom? This on the inside. So if on the inside this guy is 192.168 4.4, on the outside 20.4 will represent him. So whoever sends a packet to 20.4, that packet should be redirected to R4. How did we used to do that in 8.2? DMZ outside address 20.20.4. Simple, right? The task will be the DMZ server at should be allowed access for telnet from outside using the public address of 20.4. So 8.4 was this. On 8.4 it's a little different but easier. Object network. This is my telnet server at DMZ, or I can say DMZ 4.4. Tell me here, what do I give? Subnet, range, or host? Host, because one address. What address? Public or private? Think about the command. What does the command do? NAT inside, outside. Remember we have the command like that. What should be the host? After natting or before natting? Public or private? Should be private. 4.4. Remember? Inside. What is here? Transmit to here. Whatever is on the inside, which is specified by this subnet. Whatever is on the outside is specified by this subnet. So that confusion of high, low, low, high is not here anymore. It's not high, low, low, high. It's simple. This is here. Outside is what you specify after this. Is this static NAT or dynamic? Outside address is 20 dot. That's all you have to do. The good thing is the command remains the same. In 8.2 you had global and NAT for a separate command, and static was a separate command. Here the process remains the same. You still lose object network, object network, object network.
So for static one-to-one mapping, so we can't use the keyword subnet over here.
No. It's one-to-one. Can't use subnet. Has to be host. Okay? Let's try to do that. ASA 1 network object network. I won't call it this, or let's call it this. It's better. DMZ 4.4. Host is 4.4. NAT not inside. DMZ. Did I call it DMZ3? Yeah, I called it DMZ3. To outside. Static using what address? 20 dot. Excuse me. Seems important. Okay, so done. So NAT. So from DMZ to outside I have a NAT which is changing. Show NAT details. Source is this. Translated address is this. Always check your NAT detail. It will tell you exactly what you're translating. Static is preferred over dynamic. Definitely. Because this remains in the table always. Right? So 4.4 with 20.4. Good. Now comes the actual stuff with 8.4. With 8.2, you had to allow access to this. How did you do that? Access list, INF, permit. Permit what? Speak up. TCP from
TCP from
any to
to host.
which host?
No, 151.20.4.
20.4 equal to 23, and then you applied it in interface. You did this. This was done why? Remember, I'm blocking 20.4. Why was this done? Let's have a look at the topology. If you remember, when I was teaching you the topology, the packet is coming in more like what? From 200.1.1.1 going to 20.4. The packet comes in here. What? This is 8.2 I'm talking about. I had an ACL here. In front of the ACL was the con, then security check, then NATing, finally route lookup, or if there was any deep packet inspection, that was between the two, right? So the packet comes in as 200.1. The destination of the packet is what? 151.20.4. There is no connection table. What does it hit? The ACL. What do you allow in the ACL? This part, 20.4, with whatever port number you're trying to access, 23, and he allows you back in. What do you do in 8.4? Why? Because this is not here. This is right here. The packet comes in, right? There's no security check. Not even security check is here. Security check is after ACL. Yeah, it's after ACL. The first thing that happens is what? NAT. So this packet gets changed to what? .192 4.4, right? Can you see this is 4? Looks like a dot, right? Port number is 23. Comes in, passes the NAT. What does it hit? Access list. What does the access list say? 192.168 4.4. So what do you allow in the access list now? The packet was 20.4. NAT changed it before coming to the access list. When it hits the access list, the packet looks like this. So on the access list, what do you allow? 192.168 4.4. 192.168 4.4. We call it real addresses. On the access list, you allow the real addresses. This is easier for the network administrator. Let's make it clear. Again, on the outside I have boxes. On 8.4, 8.2 you know already. 8.4, NATing comes in the front. Then ACL. Then security check. And then the connection is formed, not the connection table, route lookup. Right? So the packet is coming in all the way from here. What does the packet look like? 200 is replying back, or 200 is trying to access the server. Which one? 192.168 4. From outside, he can't access this because this is the private address. So from outside, he's accessing 150.1.20.4. 4. I translated it to 4. Change the color of this. So the packet is coming in as, say, this red. Comes in. What is the first thing that it hits? NAT. NAT does what to the packet? Translates it. The moment it comes out from here, becomes 192, 168, 4. Also the port number was 23, it remains 23. Nothing is done with the port number yet. Right? So crosses the NAT, crosses this part, becomes this. Then reaches what? ACL, access control.
Nothing is happening before ACL, then we
Yes. So since NATing is happening now, when it reaches the ACL, if you don't have any ACL configured, that's fine. Let's see what happens. No ACL configured, goes through to the security check. Which level? What is it coming from? High to low or low to high? Low to high. Will security level allow him to go in? No. So what command do you do on the ACL to let him in? You allow which host? Permit any to which host?
192.168.4.
Equal to 23. Why? Because the packet, when it reaches, it's already translated. For you is easier because you already have to give the address of the server straight up. You don't even have to think about what is the translated address. That's why they did this. That's why they brought this in. Because for the network administrator, it's easier now. He doesn't need to know what is the translated address of 192.168.4.4. He just needs to block or allow access to 192.168.4.4 for telnet services.
सिक्योरिटी नेट पे बिना ही कनेक्शन एंट्री होगी टीसीपी ट्रैफिक
बाहर से आ रहा है ना अंदर. I'm trying to access from outside to inside, the DMZ. From inside to outside, if he's going, obviously connection entry will allow him to come back. But that also, the connection entry will be between NAT and here. It won't be here. NAT will happen, obviously. NAT has to happen today or tomorrow when the packet is coming back in. So NAT faces front, everything is behind, NAT is in the front. NAT is always in front. Good? Good enough? Clear? Anything? Any question here?
ASL will bypass sequence.
If, yeah, once he passes the ACL, he will bypass what? The security check, go straight to router.
Just one.
Yeah, just one. Earlier it used to bash. Connection table, if there is a connection table though, he doesn't go to the ACL even. Connection table bypasses ACL and security. The connection table which is created from inside, that doesn't have to go through ACL and SQ both. But now I'm going from outside to inside. So he has to bypass the security check only. Good? Clear, everybody? So let's do that. Let's do this here. Where? On this guy. I have done this. Access list should do what? Permit TCP INF permit TCP from any to host.
192.168.4
Easier for me.
equal to
I just have to know why. Server. Access group. In interface. Out. Let's do this. Access list INF permit TCP from any to host 4.4 equal to 23. Access group INF in interface outside. R2 the internet telnet 150.1.20.4 नहीं जाएगा. It did go. Any can come in, right? Any can get in. anyone from the internet. Good. Static NAT. The last one is static PAT. If there's still any confusion left here, it'll be cleared in static PAT. What was static PAT? Static PAT was one address on the outside. You only have one address on the outside interface. You don't have any pool. There is no pool. Represent is the telnet server inside on the DMZ. Telnet server on the DMZ. It should be represented by 20.10 is the outside address, port number 2300. Okay, and you also have 4.4 is the HTTP server on the DMZ link, should be represented by 1.20.10 8000 on the. You only have this one address on the interface. You can't use any other address because you have not purchased it, but you still want to do PAT. You want people from outside to be able to access inside. It's also called port forwarding. It doesn't specifically have to be 80,000. You can also have it as 80. You can also have it as 80. Also, I'll have this as 8000. On the DMZ should be allowed for telnet access at port number 23. In a tabular form, 20.10 for port 2300 should take him where? For port 23. 150.1.20.10 on port 8000 should take him where? For 80. And 20.10 port 23 should take him where? 44.4.4.4 port. One address on the outside, different port numbers take me different places. How did we do this there on 8.2? Remember? Tell me how. I asked you to study yesterday. Static DMZ outside. Address was TCP. Port number for 23. Then or there I said interface port number 2300. Also for 44 port number 23 should also go to interface. पहले interface आएगा या yes. First should be the interface. True. Control X. High low low high. Okay. So if someone is trying to go to 23, should be taken where? दो एक ही जगह क्यों जा रहे? So this is 4.4, this is 44.4 to 23, and finally someone is going to 8000, should be taken to 4.4 port graphically. (150.1.20.10). Someone is coming to 2300. The other guy is coming to 23. Another guy is coming to 80. Right? I have a server here, 4.4. 4.4 किसको represent करता है? 2300. If he comes to 4.4, he'll come where? Here. 23 comes where? 23 goes to 44.4. So I'll have another loop back here. Which will be green in color. And if he's coming to 80, he'll come where? How about access list? What access list did I apply on the notepad? On the interface. Think about the access list. Zai likho khud apni copies pe access list for this. Write it down on your notebooks. The packet will be coming from here. Internet will be trying to access these servers. To access these servers, they'll be given these addresses. So first, say for example 200.1.1.1 is trying to access the server. So his source will be this, his destination will be 20.10. Source port, random. Destination port. If he's trying to go here, 2300. If he's trying to go there, it will be 23 or 8000. Destination port only. This part will always be the same. So how many access lists would you need? 3 access lists. What would the access list say? Access list INF permit TCP from any, because the internet, to host 150.1.20.10 equal to 2300 and 23 and 8000, the outside port. Good. This was in 8.2. 8.2. Why? Think about it. This will be checked against the access list. This, whatever you're sending, will come up. The first thing is connection table. There is no connection because it's coming from outside to inside. The first thing it hits is the ACL. So you need to open the ports on the ACL to allow it in. Which ports? Destination this and destination this. This and this, 10 and 23. The same thing here. 10 and 23. 10 and 2300, 10 and 8000. So you let the guy back in. Now, this was at 8.2. On 8.4, how do you do this? Object network. You'll say this is gonna be telnet on DMZ4. DMZ3. 4. It is called DMZ3, should have been called 4. Okay. What will I do? I'll say NAT, not NAT, host. What is my host? 150.1.20.10. Only one host. And I'll say NAT outside. Then static address is what? Oh no, this is wrong. This should be 4.4.4.4. Static address should be what? 4.4 is meant for telnet, right? 4.4 is meant for telnet. static address of 4.4 on the outside will be the same interface or 150.1.20.10. Then to specify the port number, here you did it TCP first and everything else. Here you have to do it towards the end. Everything should be done towards the end. Service, it's called service. Which kind of service, TCP or UDP? TCP. Then you have to specify two port numbers, the real port number and the mapped port number. Real means the actual port number, mapped means what is outside. What is the real port number? Mapped is 23. So this will be done for one server. You'll do the same thing for 44.4. But for that guy, the inside port will be what? 23. The outside will also be 23. And also the same for 4.4. Inside port will be 80. The outside will be 8000. Right? Let's do this first. Then we'll apply the access list. And we'll see what access list should be applied. Okay? Let's do that first. Go in here. Conf free. I'll have to clear which one? The DMZ one. I'll create a new one now. Object network. This will be telnet on 4.4.4.4. Telnet for 4.4. Host is what? 4.4.4.4. NAT DMZ2. Outside is static. The outside address is interface service. What service? TCP. What is the real port? For 4.4, what is our real port? Where is my 4? Yeah, there. The real is 23. The real port is 23. So the real port is 23. And the outside port is 2300. So we'll start working. I'll do the same for what? Create another object group for DMZ. Telnet, this was telnet 4.4. I also have another telnet for 44.4, in which the host is what is this? Hey. Host is 4.4.4. NAT DMZ3 to outside. NAT from DMZ to outside. What NAT do I do? Static. What is the outside address? Interface service TCP. Real port is what? But map port is also 23. Okay. Another object network. This one will be for www in. Host is NAT inside comma outside, not inside. DMZ comma outside. Static. Interface also interface. Service TCP. Real port is 80. Mapped is. Is this clear? I didn't do the access list part. You do the access list part. Same concept, but now on 8.4. I won't remove anything, so you have the packets also. This is how the packets look like. Now in 8.4 the packet is still coming the same way. The same packet reaches the ACL. Not the ACL though. There is no ACL here. What is the first thing that it hits? So this whole packet gets converted to what? Something else. What does it look like now?
200.111.
Don't care, this can be anything.
4 dot.
So it's going to 2300. It's 4.4. 4.4.4.4 exactly, to be specific. Source port doesn't change. Destination port he changes to.
23.
So on your access list, which matches here, you'll match what? 444 and 23. Easier for you guys if you want to have a look at this is always in the access list write down the real addresses and the real port numbers. Always, that's all you have to do, because NATing will be done before ACL is checked. So you don't have to worry about what is the outside port number or the outside access list. What you have to worry about is what is on the inside. Okay, so the access list would be access list INF permit TCP from any to host 4.4.4.4 equal to 23. For 44 also 23, and 4.4 equal to 4.4 equal to 80. Access group INF in interface outside. Real port numbers and real servers, real address. Done. So now people from outside should be able to access. One small thing which I haven't done: route inside, not inside. Yes. Route DMZ. Okay, and right, so I have 4.4 as well as 44. Also IP HTTP telnet 50.1.20.10. Normal telnet will work, 2300 will work, 80 will should work. Not 80, 80 will not work. 8000 will work.
Please put the charging.
Is it clear? Right? Static PAT, port address translation. Static PAT or port address translation. Very simple. Same thing we did here. Using this has been now done using. So let me write the access list. Access list INF permit TCP from any to host 23. 44 is also 23. 4.4 is the actual port numbers, not the mapped ones. Then in interface clear. That finishes your 5, which is static PAT. There you go. Part 1.